First problem, we are getting into serious business, solving an inverse problem. Given a set of temperatures in a plain slab, you have some measurement and you want to find out what the heat transfer rate is. So there's no way of directly getting the heat transfer rate. So the normal route is we measure something which is easy to measure and which is also useful, which is also necessary. Don't measure something which is not connected to the problem. Okay, so you measure whatever is useful, and then the temperatures and the heat flux are related by a famous equation called the Fourier's law of heat conduction, which was empirically figured out by Fourier. It cannot be, it is not a fundamental law. It cannot be proved from first principle. Please note that the Fourier's law is basically when you do experiment, it is always seen that the heat transfer in conduction is proportional to the temperature difference. It is inversely proportional to the thickness. It is directly proportional to the area. So when Fourier did experiments on multiple solids, he found out there is a pattern. And then each material has a characteristic property. So this characteristic property is called thermal conductivity. But this characteristic property of a material is not complete by itself. That's what you should understand. Science means I have answers to all questions. So you have to go a little further. I'm talking about the philosophy. So beyond subjects. See, if you are characterizing a material based on thermal conductivity only from the viewpoint of heat transfer, that material itself may be required from structural stability. The material may protect you from animals. So the material's density, weight, and the material, whether it is a semi-solid, solid, it is porous, which permeability. So any matter can have multiple attributes. So through science, can we exhaust all the attributes? So this is a very fundamental question which we don't realize. When you get too much into science, you believe that science has answers to all the questions. So when I characterize a material because I am so hell bent on only calculating the heat transfer. I don't want anything else, because we feel that is the way science has progressed. We dissect, we keep on dissecting, and it's a reductionist approach. We say that okay, we'll reduce it to whatever is required, and then we don't study the full. We study only the part. But through your course of study, if different people study the part, then you can reconstruct the whole from the sum of the parts or something, which is a controversial this thing. So there is always an incompleteness associated with this. So that you don't realize, because now you're all having thirst for knowledge. You want to attend more courses, exams, this thing. So can we completely characterize anything? Yeah, even I mean, let alone human beings, just even matter is difficult. All right. Now let's get back to the ground state. Let's get down from high philosophy. Let's get down to brass tacks, as they say. We are in the domain of heat transfer. We want to study inverse heat transfer. We want to study methods in inverse heat transfer. The first method is the least square regression. The problem is posed. The problem is quite challenging. It is very deceptively innocuous or deceptively simple. It is just a plain slab, and this was the first lesson in your heat transfer, and we thought it is such a simple problem. Now I'm trying to tell you that such a simple problem can be woven into a nice inverse problem. All right. Now let's formulate the inverse problem. So it's a sheer beauty. So I'm just enjoying this new board and new chalk. Sometimes when they call me for other colleges, of course, last 1 year I didn't go anywhere. The last time I went on a flight was to Shastra University on March 14th, and March 16th, all the institutes were closed. Okay. When they give me a white board, I'm all at sea. I'm like a fish out of water. So I like this black or the green board is also nice. Okay, the formulation of the inverse problem. Okay, so d by dx okay, all right. Now in 0 less than equal to x less than equal to l. Okay, so because that is 0 on l, this is the length of the slab, thickness of the slab. Okay, q equal to minus this question mark. Dear students, please send your ID numbers through this form to mark your. Okay, today we are sending the roll list in the afternoon, okay, to the academic section. All right. So Q equal to minus K dou T by dou is unknown. T equal to T1 at x equal to 0 equals unknown. T equal to T2 at x equal to L equal to unknown. Okay. T x measured of I equal to I equal to 1, 2 up to n. This is given. Okay. The goal. Yeah, just write down. Is it okay? Shall I proceed?
Yes, sir.
Okay. Goal to estimate, to recover, to retrieve. Okay. Retrieve means is get back. I told you know the golden retriever dog. The golden retriever dog will retrieve stuff for you. That's why it's called, and it's a golden color. That is a golden retriever. A retriever is somebody who will retrieve things for you. What is that retrieve? Here, I want to retrieve Q. Okay, because it's fundamental to me. The goal is to retrieve, estimate, recover Q. Okay. So this is the formulation of the inverse problem. Therefore, please note that formulation combines yeah. Can you tell me the formulation combines what all? Formulation combines, please. Please go ahead. Don't worry about try.
Defining,
Okay, I have a quotation. Huh?
defining the problem
What is that defining the problem? You are
with
defining
all the
inverse problem.
boundary conditions and stuff.
What is that called?
Uh,
Technically. I called it something, no, last class. Parshini.
I don't remember, sir.
What did I call it?
Forward model.
Forward model. Correct. Forward model. Then what else? Apart from forward model, many things are there. What else is there? In the inverse model.
Optimization and then
Optimization, I have not told. Method is not there.
Measurement.
Measurements.
Measurement, exactly. Measurement is there. Measurements, not measurements. And then
Statistical
something
knowledge.
which you
Statistical knowledge. Statistical knowledge.
statistical knowledge is not here right now in the formulation. Solution
Assumptions.
Assumptions are there in the forward model.
Stopping
Huh?
condition. Stopping condition.
Inverse model. Inverse
Stopping
model.
condition and all comes only when there is a
Inverse model.
Inverse model is not there so far. I mean, only the inverse problem is formulated. There's something which you are missing.
Sum of residual.
Huh?
Objective.
Simulation.
Huh?
Estimation.
Estimation.
Residual. Sum of residual.
Some of the residual is not the inverse problem. Who is that? Who is saying that? Don't worry. You just tell who is saying that.
Sir, I am.
Ujjwal. Hey, some of the residual is your idea, correct? That is your idea. It may be correct or I'm not saying it is right or wrong. That is a, but at this stage it is not introduced. But there is something all of you are missing.
Objective.
What?
Goal.
Unknowns. There is an unknown, right? Unknowns. The inverse problem declares what are the unknowns in the problem. See, look at how many places I put question mark. Where are the places I put question mark? Q is a question mark. Boundary condition is a question mark. Left side boundary, right side boundary is a question mark. Normally, if these two question marks are given to you, directly you will get the Q, will solve the forward model. But now, we have not given the boundary condition. We gave ajar temperatures. That makes you confused. It is confusion worse confounded. Okay, you don't know what to do. Okay, now but it is our Guruji, Fourier Guruji is there. So what will he tell us? Okay, guys, if you find out the temperature field, that means if you have a function estimation, directly trying to find out what Q is, if you have a function estimation for the T, then Fourier has set a path where dt by dx into k is Q. Therefore, instead of blindly trying to recover, blindly trying to retrieve, so trying to, in this case, it is too much to give that example. Normally, we'll say searching for a needle in a haystack. Instead of blindly trying to, that's what the data scientist will do. I'm sorry to say, this may be recorded. I may put it on YouTube also. Data science, what is this helter-skelter search? Pure data science. Sushruth is there. Sushruth? Where are you, Sushruth?
Yes, sir. Here.
You come on video.
Okay, sir.
Sushruth is my 5th year dual degree student. He's a big fan of data science. Correct, Sushruth?
Inverse, sir, not data science.
Inverse. So you feel anything and everything can be inverted in this planet?
No, sir, not
What is your
exactly
approach? What is your belief?
With
But you
right
want to invert.
approach,
You
with
want to
right
invert.
approach, we can.
With the right approach, you can. Okay, that is, you're talking like a scientist. But you feel that inverse is exciting?
Yes, sir.
So Sushruth was in the first batch of this post 2019, and then he's refusing to go away from me. Some mini project, maxi project, this project. The last 3 years, Sushruth is with me. Now he is also saying, no, sir, he's doing project. But he says, no, sir, I like inverse. I say, every day he will send email. Sir, I want to be TA, I want to be TA, I want to be TA. Okay, so we have taken Sushruth. He's going to graduate now. What are you going to do after this, Sushruth?
Sir, ITC.
PhD? No, you're taking up a job. ITC. 27 lakhs.
No,
How
sir.
much is that?
25.
Salary?
25.
Oh, 25 lakhs. That's what the prof will get after 20 years, man. But I'm very happy. Our students do well. We are doubly delighted. That's why we are teachers, right? Our students should overtake us. All right. So, Sushruth, I don't know why I called you on video. I forgot the original purpose. Why did I call you on this?
So formulation, I don't know.
Data science. So I want to take pot shots at data science. So there's no point in having a helter-skelter search, right? There's a lot of data. I'm trying to get you. That's what you can do. But I will come back to that and say that how sometimes it may help. If many people are buying smartwatches, I'm also interested in a smartwatch now because my smartwatch count off. Okay, so it's 3 years old. So for consumer behavior, other things, it may helter-skelter search, neural networks, artificial intelligence, machine learning may work. But I think it's good to have a forward model. What do you feel, Sushruth? It's good to have a good sound forward model, right?
Yes, sir. Yes.
No. All right. Okay. All right. So I won't make you conscious. You can just turn off the video and I'll call you at the right time. Hey, Sushruth is going to grade the first that Maruti Service Center. Of course, I will talk to him. I'll also take a look at what he's doing. He has been volunteered to do that. Okay, Sushruth. All right. Okay. So just turn on the. So Sushruth is in the 10th semester. Okay. Of dual degree. All right. Now, the formulation combines forward model, measurements, and unknowns. All right. So this is how the inverse problem is posed. Now you tell me, Ujjal.
Yes, sir.
You're a big fan. I think you're a big fan of regression. Show your face. You're a big fan of statistics, it seems. Is that right?
Sir, medium.
Hey, don't get conscious, man. Don't get conscious. You know that I'm pretty cool. Okay, and I'm far away, so we can't do. So, hi Ujjal. Hey, you're in dual degree or BTech or
Sir, I'm dual degree. I'm doing MTech in data science.
ME17B? MTech in data science. So he's a firm believer of data science. Okay, so we are also doing data, but we are saying that data science should also be accompanied by physics. That's what we are saying. So don't divorce the physics completely. Okay, we can make the marriage work. That's what we are saying. Okay, so since you are a strong advocate of data science, so you tell me what is the next step? How do you solve this?
Sir,
You are in the 8th semester, right, Ujjal?
yes, sir.
You are in the 8th semester. Okay, so already you should take it. So how do we? So okay. Now solution. How do you solve? Please note that there can be हजार ways of solving it. Just say one approach could be your favorite. What is that?
Regression, reducing the sum of
Regression.
square
Okay.
error.
Okay. So regression. In regression, he says, okay, you can turn off the video to save bandwidth. Okay, Ujjal, thank you. So I have seen you. Okay, so you are real. Okay, so this is least square regression. I don't know that. See, you just check up the wiki. Least square regression or least squares. Sum of least squares. Okay, maybe least squares regression of least square. Both are okay. So this is please note that this is what I am saying. What we are saying now is sigma I equal to 1 to n t measured I minus t simulated I whole square by sigma I squared. What is that sigma I square? That is the error with the instrument. So this I can call it as r squared, or no, I will say r dash square. Okay. Now, if sigma I is not a function of I equal to sigma, okay, then hey, did you see this is really fancy? So I just keep it like this. Okay. So this is some fun. Okay, the new board, but I should figure out this magnetic. Okay. So if you want to do some SO, right, that show off, you can just do this. But I will keep it safely somewhere. Okay. Now, what is the sigma? Okay. Sigma I is the error in the ith measurement. Here, ith, here it is ith TC. TC means thermocouple. TC means thermocouple. Okay, very good. Now, this is a, okay. So this is one as further assumption. This is an assumption. Okay. That is sigma I. So what happens if the each measurement has got a peculiar sigma? That also you can handle it this way. Now we are taking the little bit special case, which is little bit relaxed, where sigma I is not a function of I, so it is sigma. Therefore, r square into sigma square can be called as r square. So r square equal to sigma I equal to 1 to n T measured I minus T simulated I whole square. Minimize R squared. Minimize R squared. To get something. From that something, get Q. So we have to solve the inverse problem. What is the heat flux? That is what. Okay. So please note the goal is to estimate, recover, and retrieve or I have a forward model. I have a set of measurements. I have a set of unknowns. Whether the unknowns are, if you get the unknowns, I will solve the problem. Whatever, I'm not even saying any of this. This is the forward problem. Now I'm saying that consider a regression. This regression is a least square regression. So there is an assumption that the least square is the best. That can be questioned. Anything and everything can be questioned. No theory, no hypothesis, no proposal is so sacrosanct that it cannot be questioned. So if you look at the origins of scientific progress, people ask questions and they try to answer. When they try to answer questions, they ask more questions. That led to more answers, more questions. We are continuously and asking questions. That's why we are continuously improving. Correct? People wanted to ask a question. Okay. Why should there be stylus in a smartphone? Why should there be keypad in a mobile phone? Who asked this? Okay, Steve Jobs. What is, at that time, BlackBerry was ruling. This fellow is crazy. Why? Of course, without the keypad, people will finding it difficult. So what did Steve Jobs say? I will make the whole screen into keypad. Okay. Then for typing, what will they do? They were using a stylus. The stylus is the first thing people will lose. Okay. Finger is the stylus. What? He's doubly crazy. He wants to not only remove the keypad, he also wants to remove the stylus. He says that only crazy things can change the world. Please read his biography. It's so big, right? Now you're in lockdown. If you have some time now, of course, you're having Zoom classes all the time or Google Meet. So he says only crazy people can change the world. So both of this he did, and now it is history. Now all the phones follow this. So all the phones follow this model. In 1968, the Olympic Games, Dick Fosbury, F-O-S-B-U-R-Y, Dick Fosbury, he had a strange funda. He said in high jump, everybody is going like this and jumping. And then you're able to cross only this much height. He says that I will run backward and jump. During his training, he figured out that if he runs backwards and jumps, he's able to cover higher distance height compared to what you would do in the forward distance. So according to the Olympic rules, there is nothing less. You should come forward and jump. You have to clear that obstacle. So he did that. And then subsequently, all the Olympic champions use the backward jump. This is called the Fosbury flop. Okay. Now Fosbury flip flop. Okay. Fosbury flip flop. You can just Google it up. So it changed. It changed the way people thought about things. That's why. So can we be that? Can we be that? That is the dream of everybody. Can you be that? Not just will give me a lot of wealth and somebody will become like Jeff Bezos or whatever. So it will impact a lot of people. It will make a change. All right. Now let's get back. So in this case, you should question. You should question. So the question is, we should not forget the question which led to so many things. Okay. They said, what is the most fascinating journey in the world? The most fascinating journey in the world is the journey through the dictionary. Because you want to find the meaning of a word, it will lead to some other word. That will lead to, so you will not close it at all. So like that, when you go through a chain of your thought process, your chain of thinking, you should not lose track of why, at least in a class, you should not lose track of why you asked that question. Now the question now is the least square regression the be all and the end all of everything? Is there no other way of doing it? There are many other ways, but the least square is very good in the sense that it gives a unique solution. It doesn't leave you uncomfortable. It gives you finally, when you do everything right, it will give you one value of Q. And from the viewpoint of engineering, you know that this slab should have only one Q. You cannot have multiple Qs, which may be a mathematical possibility. It is an engineering impossibility. Therefore, whatever you do, regardless of whatever approach, statistics, data science you use, finally, you should get meaningful numbers. You should get meaningful numbers. So this regression, trying to minimize the difference between T measured and T simulated. T measured, all the 6 temperatures are given to you in yesterday's class. This T simulated will come from the forward model. So this one, so if you do this, so this least square regression. So LSR, the LSR is a proposal. So the inverse problem, different people may solve it differently. Quadratic equation, ax squared plus bx plus c equal to 0, x equal to minus b plus or minus root of b square minus 4ac by 2a. This in sleep also we'll see. Everybody will same approach, same solution. Here, sky is the limit. Data science guy may approach it differently. So calculus based guy can approach it differently. Somebody can use least square regression, somebody can use probability, somebody can use probability and statistics, Bayesian statistics. There are many ways of solving this. Okay, now this sets up the framework. Now we have to complete this least square regression. Any doubts so far? So I'm just laying the foundations for an inverse. So all this is general. Though, particularly those people who are very much interested in data science, you see that this is also the way in which data handling data, all these pandas work. You can apply to any. So this T measured minus T simulated can be anything. It could be share price, it could be whatever. Okay, it could be the GDP forecast, GDP growth rate or something, whatever you can put it in finance, economics, microeconomic, demand, supply, whatever. All right. Shall we proceed? This is okay. Okay. All right. So at least today, the board is a treat. Let's see how long it remains like this. The board is a treat. The duster is a delight. Not bad. All right. Now, LSR. LSR to solve problem 1. Okay. That's correct. Let me check the notes to see whether I've used Y or T. I've used T. Okay. So this is okay. In our case, the capital N was 6. We had 6 measurements. Okay. So this is the most important steps we have taken in the morning. So this Ti is actually the measure. So this is actually the T simulated. Is that okay? Did we start using the numbers already today, or can we call this as 1? Oh no, I gave some numbers for the inverse model. So please tell me the correct number for this. Anyone?
6.
6. Okay. Very good. So we want to minimize this. So this can be taken as S. Why S is called? What is this S and all that everybody uses? You can use Z also. S is very nice because it is sum of residual sum. So there is the first guy who thought about it. I mean, so he didn't come from heaven. He was also had a body. He was like us. He had a brain. All that. So the first guy, because he put R, he could have put gamma or something. He put R. R is the residual. So to call it. So the mathematical symbol for this thing uses nomenclature is R, capital R. Then somebody said R square is equal to S. Fine, very good. S is the sum of the residual. Now we do dou S by dou A equal to 0. Dou S by dou B equal to 0. So two equations, two unknown. It can be solved. Two equations, two unknown. Let's do this. Equal to 0. Yeah. So just take a couple of minutes. I wrote it fast. Just absorb this. I'll wait for a couple of minutes. People who are still doing, no problem. Take your time. I'll give you a couple of minutes. People who are restless, who already have come to this step, go ahead and solve the two simultaneous equations and get expressions for A equal to B equal to. Get this? Then what we'll do is, we'll apply to the data, which we gave it in yesterday's class. Then we'll complete the problem. It's going to take another 20-25 minutes. It's well worth it. Now, just absorb this funda. Sum of residuals. You can pin sir's video to avoid switching. That's okay, fine. ME18. Okay, you're exchanging some messages, which is fine. So people are trying to ensure that the class is not disturbed, which is also okay. Just go ahead. So done. The differentiation was quite all right, isn't it? So did I make any mistake? Is it fine what I've written? Hello?
Yes.
Very
Yes,
good,
sir.
very good. Okay, now let's work on it further. Equation 9 becomes the equation 9 becomes sigma xi ti minus, you can take care of the minus a sigma xi square minus b sigma xi equal to 0. Okay. sigma xi ti, a is a constant, minus a sigma xi square minus b sigma xi equal to 0. The 10 becomes sigma ti minus a sigma xi sigma of b n times minus nb. So this is sigma of b, b1, b2, b3, b 6 times 6b. Okay, all right. Okay, 11. So the two unknowns are a and b. You can solve for a and b. Okay. So for starter, I will help you with the, just say that b sigma xi So if you substitute for b here, equation 12 will become sigma ti minus a sigma xi minus sigma xi ta minus a sigma xi divided by a sigma xi square divided by sigma xi into n. Okay, so equation 12 will now become an equation in a. Therefore, a equal to, yeah, I'll just give you a couple of minutes so that you do it yourself and keep it in the notes. Anyway, the exams will all be open notes, open everything. Okay. If you do it yourself today, that means you don't have to prepare for the exam. You know how to do it. Okay. You're all smart kids. So if you do it once, you will remember it. That's why don't copy it from the board. Do it now. Now you're relaxed. It's not an exam and this thing go. You can do it. Please do it. So I will try to clean up the board this side. So I got the A and B. Just check whether you get the same thing. A equal to n sigma xi ti sigma xi sigma ti divided by n sigma xi square minus sigma xi whole square. Please note there is a difference between sigma xi square and sigma xi the whole square. B equals denominator will be the same for both as it should be. Okay. Is it okay? I think you're still doing, so big class is very serious. Do it and get it. I'll wait for 5 minutes. No worries. Just do it. Very good, Anand got it. Just do it yourself. Just do it yourself. I'll give you time. Just do it yourself. It is not rocket science. Okay, it is easy to do. Do it. It's not great math. Simple. Okay. I already saw 2 hands. Very good, Subhash. It will give you immense confidence if you do that. So if you just follow my step, do it yourself, and it is a lot of liberation, right? Doing something yourself is liberation, right? So you know it, that the removal of darkness or ignorance. Okay, of course, you are ignorant of many things. So the key thing to studying anything is we should know what we don't know. Okay, what you know, you keep it aside. If you want to make any progress, you should know what you don't know. Only then you try to find out. If you think you know everything, you cannot learn anything, because you already assume I'm a genius. Whatever I don't know is not important, is not required. There is no progress. Okay, you should approach any subject, whatever be your age. Approach a new subject with a boyish enthusiasm, and that enthusiasm must be the fire which fuels or the fuel which fuels the aircraft, which fuels the car or whatever. So that all of you have struggled hard in GATE, JEE, this thing, for some reason you want to come to IIT. So it's not easy to come. It's not easy to join the Zoom meeting either as a student or as a prof. Many of us don't realize. Not everybody can join the Zoom meeting. If you just open up the Zoom meeting to 1,000 people, they won't understand what is going on here. So it requires a certain level of knowledge, preparation to understand what you're doing. That you're already there. Unless you have focus, you would not have come to this stage in life. So what I'm saying is, so please think about this, that you're all of us, you're all capable of focusing, you're all capable of doing. You should have fun. You should watch a web series, YouTube movie, whatever. But just like a compass will point to the true north whenever it is not disturbed, you just see what your goal, long-term goal is. It could be anything, but to take something which is high, which is difficult to reach, and progress towards that, so that you don't feel this emptiness. What is this? What is the point in doing anything? What is the point? And so, okay, look at Abdul Kalam, look at Vikram Sarabhai, look at all these people. All right. Now A and B are okay. Now, therefore, what? So, what is required? What all are required? We are going to solve it in tomorrow's class. But before that, so we have to get sigma xi. We have to get sigma xi. Sigma yi. Sigma xi yi. No, not y. I wrote it as t. Then sigma something. Sigma
xi square.
y square. Correct. Exactly. So 4 fellows are required. Who are the 4 fellows? Sigma xi, sigma yi, and sigma x is special, sigma xi square, and then sigma xi yi. Once you get all these 4 things, first calculate the denominator. So I am telling you a foolproof method of retrieving. Okay, get the denominator right. Okay, store up to 4 or 5 decimals, because if it is something 10 to the power of -3, -4, if all are small quantities, and division by small quantity can lead to a large quantity, and it could lead to large errors and open notes and all that. I mean, for the purpose of exam, what I'm saying, I have more than 10% error, we will cut marks and all that. I mean, marks and all is okay. It's this thing, right? So it is a necessary evil, because you have to grade and all. But what I'm saying in real life also, division by a small number has to be. Division by a small number is why many computer programs couple. That is why we have double precision and all that. So division by a small number is a very dangerous thing. It is a singularity, lead to singularity. Okay. Anyway, so keep 3-4 decimal places in the calculator. Don't approximate. That will be very clear in this problem itself. So sigma xi, sigma ti, sigma xi ti, sigma xi square. If you do this, then we will we are in a position to solve. We are in a position to get A and B. Okay. Okay. Then what next? What is the next program? So T equal to AX plus B. We get A and B. So T is a function of X. T is a function of X. So temperature field is estimated. Please note that the regression gives you a temperature field which is an intermediate. Your goal is to get Q, but I am telling you there is a heat transfer route to get Q. Okay, then work further. Okay, Q equal to minus K dt by dA. Minus K. Okay. So we are home. Now you say no. Buy one, get one free. Buy one, get one free. No, it's a freebie. I'm saying buy one, get two free. What are the two get twos which are free? Huh? In this problem? Can you tell me? Hey, am I audible?
Yes, sir. T0 and Ti.
Hello? Exactly. There you are. So T1, T2 equals X equal to 0, X equal to L. Okay. TL. It's free. This is the bonus. Working so hard, sweating it out, using least square regression and trying to solve the problem. It's a very compact, nice problem. So we can convey a lot of ideas through this. Okay. So this nitty-gritty of this problem and all that, Suraj has solved it, and this thing yesterday has shown it, but we're going to solve it tomorrow. So using the long route, every column. So if you see, Pandai, since you got xi, ti, and this thing, we can be very systematic. Of course, you can solve it on Excel. In the classroom, we'll solve it we'll solve it on the using a pen and paper. We'll put up a nice tabular column, and then we'll fill up the columns. Then we'll put the summation, and then substitute for A and B and get it and Q, and then we are home. And then and then we can confidently say we solved the first inverse problem in the course. Now, is this the only way to solve it? Certainly not. What are the other ways of solving? I just prod you to one more way of doing it. Okay. I know that A and B are causing this, T equal to AX plus B. So what I can do is now, it may be unimaginative, but this is how the a data scientist may approach this problem. So take 20 values of A, take 20 values of B. So 400 pairs of A and B you generate. Okay. So 400 pairs of A and B you generate. Forget about the regression order. Take 400 pairs of A and B. For each pair of A and B, I can get T1, T2, T3, T4, T5, T6. Correct? These are all simulated. I also have the measured. So now and then what I can do is I can bypass all of this and just report only sigma r square. Correct? So let's say that I will do Now, I can do this R square versus A. Okay. For a particular value of B1, B2, B3, B4, I can find out how the R square varies with A. Then I can ulta the plot and make it R square as a function of B. Or I can just use Excel out of these 400 pairs, I can rank and find out. So this is the best value of A and B. So this is a completely data science approach, which completely bypasses the physics. So for certain problem, if the physics is so hard, if you just don't know what is going on, it's like the human body and so much of dynamic. This is not a bad approach. I'm not saying so. We also use data. We should not keep on tulping data science. So data science is useful. So where there are challenges in the modeling, okay. But the caution there is, did you choose the right values of A and are the values of A and B reasonable? Your range. Who will tell you all this? So if you can get guidance from the physics, if you get guidance from science and engineering, then it will not be a blind computer science approach to the problem. But even if it's a blind computer science approach, if you're a mechanical engineer, you can get a little smart, you know what the heat transfer, so you know that Q equal to minus Ka, and then thermal conductivity is given to you. So you will get an idea of in this slab, how much can the slab transfer? 1 kilowatt, 2 kilowatt, 3 kilowatt, 4 kilowatt. So what could be the bounds of A? What could be the lower and upper values of A? If the bounds of A, so first guess the value of A, so the bound, put that bound into that temperature T equal to Ax plus B from the measurement, and then try to guess the bounds for B. Now, instead of just taking A equal to 0 to infinity and B equal to 0 to infinity, if you use your prior knowledge, if you quantify your belief that these are the likely values of A and B, because it's a physics problem, it is not a computer science problem. It is after all a slab, it is in ME, it is in thermal engineering, it is in heat transfer, it is a plain wall, I know it is a solid wall, it is some brick, it is in composite, whatever. So if you bring in your fundas, then you will do much better than a pure data scientist. So if you're able to marry measurements, if you're able to marry measurements with the forward model or your big data and your beliefs, and then you're good in probability and statistics, then you can do wonders. And the world is wide open. The kind of problems which you can solve is amazing, incredible. Instead of just course after course after course, just solving the forward model, just break free, then just cut down, remove the shackles of mediocrity, remove the shackles of this thing, getting constrained by problem is there, differential equation, solve. Instead of that, look at the things with look at the outside world with open eyes. There are a set of observations. There is some underlying phenomena which is governing this. Can I figure out? Can I extract more information than what is possible by just analysis? I'll stop here. Tomorrow we'll complete this problem. Any doubts so far? I think it's time for the next class. Shall I sign off? Okay, so data science students will be happy today, the dual degree. Sushrut, are you happy? Oh, you're not data science. Okay. Ujjal, are you happy? Okay. I think, what happened to him? All right. Chalo. Okay. So go to the next class. See you around. Bye.